All right, so today we're looking at vertex form. So vertex form of a quadratic function is y equals a times x minus h plus k, where h and k are the vertex and h is the axis of symmetry. And again, we can determine the width or the direction of the parabola based off of our a value. So there's our first lines. The vertex form shows us the transformations on a quadratic. And in respect to its parent function of y equals x squared, which is our parent function for all quadratics. And so again, our vertex form is telling us where we're changing, right? Our h value again is our x value or our axis of symmetry on our vertex. Our k is our shift up or down on our vertex. And our a value tells us if we open up, that U shape, or if we open down, that hill shape. So with that in mind, let's look at a few of these problems. So it says, describe each function compares to its parent function. So number one, we've got x squared plus 9. So not quite exactly in vertex form, because we're missing this. Got to put my squared there. So we have x squared plus 9. So in this case, our h value, or our axis of symmetry, is not there, right? There's no value in here. We just have that x. We can think of it as a plus 0 or minus 0 squared. That would be the same thing as that x squared. So in this case, our h value is 0. Our y value, or our k value on the outside, is a positive 9. So our vertex is at 0, 9. Our a value is our leading coefficient, or the value in front of our x squared, which is 1, which means we are positive, and we are opening up. So in this case, the only thing that happened is we shifted our vertex off of the origin, and we shifted up 9 units. So we can say we had a vertical translation up 9 units. Okay. Number 2, again, same idea. We have that x squared minus 2. So in this case, again, we only have that vertical translation. This time we're going down 2 units. Nothing else really happened. So again, that's based off of our original parent function, y equals x squared. Number 3 is where we start to have our first signs of our vertex. So we have negative times x plus 5, that quantity squared. So our h value in this case, or our location of our vertex, again, if we look back at our original problem, it's minus h. So we're actually going to do the opposite of this. So our x value of our vertex is negative 5. Our k value does not exist, which would mean the same as adding 0. So our k value, or the y value on our vertex, is at 0. So we're at negative 5, 0 for our vertex. Our translations or transformations that took place, we shifted to the left 5 to get that vertex. So we have a horizontal translation left 5 units. And we also have this negative out front. Our a value is negative 1, which means we have a vertical reflection across our y-axis because it's a negative leading coefficient. The 1 means we do not stretch or compress at all. So let's look at our next. Number 4, we have f of x equals x minus 4 squared plus 1 minus 1. So our vertex this time is going to be opposite of the inside. So positive 4, same k value, so negative 1. So our vertex is at 4, negative 1. Our shifts, we have a horizontal shift or horizontal translation right, 4 units. And we have a vertical translation down, 1 unit. And our A value is a positive 1, so nothing happened there. Let's look at some. So number 5, we have f of x equals 1/3 x squared plus 2. So our vertex, again, we do not have anything in the parentheses. We do not have that h value, so that's a 0. But we do have that plus k value, which is 2. So our vertex is at 0, 2. Our transformations, again, we don't shift left or right any because our h value is 0. But we do have this 1/3. So in this case, we have a vertical compression by a factor of 1/3. And we have that vertical translation up 2 units. Okay. And then number 6. F of x equals negative 2 times x plus 4, that quantity squared. So our vertex, again, opposite of h, so negative 4. Our k value is 0, right? It's not there. So our vertex is at negative 4, 0. So then let's go through our transformations. We have that shift to the left, opposite on the inside of the parentheses. So we have that horizontal translation left, 4 units. We have that negative a value, so that means we have that vertical reflection. We're also multiplying by 2. Our a is negative 2. So we also have a vertical stretch by a factor of 2. Not just that vertical reflection, but we also stretch. And then our k value is 0, so we don't have any translations up or down. So again, that's based off of our parent function of y equals x squared. We've shifted to the left, we've reflected, and we've stretched that graph by a factor of 2. Number 7, now they're giving it to us in a sentence form. So Mason graphed the parent function of a quadratic equation. Then he reflected the parabola over the x-axis, translated it 7 units up and 3 units to the right. What is the equation of the new parabola? So again, let's put all that together. Again, here's kind of our basic. And so first thing he did is he reflected the parabola over the x-axis. To reflect, we have to multiply by a negative, so we know our a value is going to be negative. We have a negative here. The next thing is he then translated it 7 units up. Well, to translate up, that's going to be our k value. And we went up, so that's a plus 7. And then 3 units to the right. Well, if we went 3 units to the right, we want to do the opposite on the inside, so we want to subtract 3. That'll move us to the right 3 units. And that's it. So here's our new equation. We have a negative. There's our vertical reflection. Our shift to the right 3 units, so minus 3. And our shift up 7 units, so plus 7. Next thing it says, give the vertex and the axis of symmetry for each function, then graph it. So in this case, we're going to use our calculator to help us. But first, let's find our vertex. So number 8, we've got f of x equals x minus 2, that quantity squared, plus 3. So our vertex in this case, again, opposite of the inside, so 2. And then our k value is 3. So our vertex is at 2, 3. And then we have our x and y table. And so we know our vertex is at 2, 3, so that's going to be our center. And then we want to grab 2 or 3 points to the left, 3 points to the right of our vertex, which is at 2, 3 again. And so we can do that very easily using our calculator. We want to plug in our equation. So go to y equals on our graphing calculators, parentheses x minus 2, that quantity squared, plus 3. And then we want to look at our table, so second table. So I want to grab 3 points to the left. So that'd be 1, 0, -1, and 3 points to the right, 3, 4, and 5. So when I'm looking at my table, at 1, I'm at the point 4. At 0, I'm at 7. And at -1, I'm at 12. These are going to be those exact same values, right? Because we have that axis of symmetry on our vertex. So at 3, I'm also at 4. Then I'm at 7 and 12. And our calculator verifies that, right? The left side and the right side are going to be identical because of that axis of symmetry. So let's look at one with a negative. So let's look at number 10. First, let's graph this. So we have the point 2, 3. Then to the left, I'm at 3, 4. At 1, I'm at 3, 4. Again, because we have that axis of symmetry. 4, I'm at 7. Off my graph. At 0, I'm at 7. There's our graph for that function. Let's look at number 10 now. So we have f of x equals negative x plus 5, that quantity squared, minus 1. So again, our vertex is at the point opposite h, so -5, and our k value is the same, -1. So we can go ahead and put our vertex on our graph. So -5, -1. There's our vertex. I know I'm going to open down because we have that negative a value. So I'm not going to have any x-intercepts in this case, so there is no solution to our equation. Let's find some of these other points. So we're at -5, -1. Again, I'm going to go to my graph, plug in our equation. So we have negative x, or negative times x plus 5, that quantity squared, minus 1. Now I want to look at my table. And here's my axis of symmetry going right through our vertex. So I'm at -5. So I'm going to go a little bit farther to the left, -6, -7, -8, -4, -3, -2. So -5, I was at -1, -6, I'm at -2, -7, -5, -8, -10. Of course, our opposite side is going to be a mirror image across that axis of symmetry. So So -6, I'm at -2. At -4, I'm at -2. -7, I'm at -5. And same thing at -3. And there we go. There is our graph of that quadratic. And that's it today for our vertex form. Again, vertex form, your vertex value is the opposite on the inside, and your k value is your y value of your vertex. Your a value determines whether you open up or down, if you have a stretch or compression based on the value that you multiply by. Have a good day.